Hello, community! Generative AI. Our beautiful AI models like ChatGPT or GPT-4, let's have a look at them and explain the basic terms. We have two worlds. We have the closed world of GPT-4, which today we assume it is a system of 8 GPT systems, each trained with 220 billion free trainable parameter. And on the other side, on the right side, we have systems like MPT-30B, which is open source, and we know what's happening in the system. But the beauty is both systems have the same architecture of the neural network that runs on self-attention. Pre-training is the most important and the most expensive step to include intelligence into an AI system. OpenAI had about $3 billion to do this. On the open source side, now almost 1.5 years later, we know the data. We know a 30 billion trainable parameter model you train on 512 NVIDIA data center GPU. Alone the compute cost for the perfect run costs about $1 million. It takes 2 months and has a data set of 1 trillion token that can consist of 10 open source text corpora. Unfortunately, MPD has been bought by Databricks. This startup is not available anymore. So you see, closed source and open source has some significant differences. Now, GPT-4, we know, about 1,000 to 10,000 GPUs in Microsoft Cloud Compute. The dataset was the internet. But the technology evolved. We have new technology today. GPT-4 used something like reinforcement learning. And Stanford University came up just months ago with a new, clever, intelligent algorithm. So you see, we have a massive technological development that we can use also in open source. Now, this DPO or direct preference optimization offers a significant advantage over the old PPO by directly optimizing a language model to align much more with human preferences without the need for reinforcement learning. And this is something great. We have a new methodology we can apply on all open source model. So thanks Stanford for this. But talking about the investment you need, let's have a look at Inflection AI. 1-year-old startup, and Microsoft and NVIDIA invest $1.3 billion just to provide the compute infrastructure of 22,000 GPU for this startup that is a direct competitor to OpenAI, and in both companies Microsoft bought itself in. Fine-tuning. Fine-tuning is something beautiful because, and you're not gonna believe this, fine-tuning does not exist on the closed source. OpenAI and Microsoft do not allow you to fine-tune their GPT-4 system because it alters their system, it modifies their system. On the open source side, we can fine-tune our pre-trained language model, and we do this for a specific task like summarization, translation, sentiment analysis, dialogue system, question and answer system, or the latest for educational purposes. So fine-tuning you can get your fingers on, and in open source model you can here experience what it means to further optimize your LLM for a task. Here are 2 pages from Hugging Face, and they show you how to fine-tune a pre-trained LLM. We have here a framework language, it's called PyTorch, or you go with TensorFlow 2, or you use a simple Hugging Face trainer. And on the right side, you see here a Jupyter notebook by Google, free of charge. Click there and you're into coding your fine-tuning. Now we know that here the cost to fine-tune a pre-trained LLM is not so expensive. The cost for a 30B model is about $1,000 to $10,000 per 1 billion token, if you run with a bfloat16 precision for your mathematical operation. But the most important factor is the quality of your fine-tuning dataset. Fine-tuning, and please, this is important, involves updating all the weights in our transform architecture of the pre-trained LLM by training here this model, by running this model on a specific data set that you want to learn here the intelligence that is hidden in the data set, the model with. Of course, what pre-trained LLM you use is important, and I focus here only on commercial use. And you see we have only 2 models in the 30 to 40 billion range, like Falcon 40B and MTP30B, that are really open source in a commercial sense, and then we only have T5 in advanced UL2, it's an advanced T5 from Google. And you might say, no, we have here open source, look at the leaderboards. The last column is the license. I have here the license for you, and the first 12 LLMs on the leaderboard have non-commercial license. Whenever you see Llama, you have a non-commercial license. Whatever you do in programming, you do it on the research license, and the moment you want to make $1, Meta says no, belongs only to us. Open source is great. We can do the classical fine-tuning with a dataset on a pre-trained LLM. We use about 12 to 24 GPUs, and we have a good precision like bfloat16. But sometimes this is too expensive, so we have here the memory-optimized fine-tuning. The idea is to put it on a single data center GPU with 40 or 80 GB of VRAM. There is some notions. Parameter-efficient fine-tuning, one methodology is LoRa, and quantization of models. LoRa stands for low-rank adaptation, and it freezes the pre-trained model weight tensors and injects some trainable rank decomposition matrices, this is a mathematical term, into each layer of the transformer, significantly reducing the number of trainable parameters for the downstream task. We call this adapter tuning. This is the video for you to learn on PEFT. This is the video if you want to code PEFT in 8-bit quantization. And this is a video here I did on 4-bit quantized LoRa system theory and code for you. But there are other ways we can optimize here the fine-tuning. We optimize the memory access, the hardware access. We have flash attention, and we have VLLM that uses paged attention. So you see the attention mechanism is all over the place, but you have to understand what it is. June 2022, we had flash attention. In June 2023 from Berkeley, we have paged attention. Both optimize your memory management software hardware interface. You can go for efficiency, for flexibility. There are a lot of mechanisms available today that we learned how to further optimize LLMs, how to make them more intelligent. But having talked about better models, better hardware memory access for the GPUs, the most important factor is, of course, a high-quality fine-tuning dataset. And we have here instruction datasets. What is this? Now, a non-instruction-based training dataset to fine-tune an LLM is this. The sky is blue, the sky is orange, the sky is. And now GPT-4 as an autoregressive system comes up with the next word in the sentence. Now, GPT-4 might think, hey, I give him all the colors that I know of, 100 million colors. If, however, you say I use an instruction-based training dataset for fine-tuning, I give GPT-4 the instruction to describe all color combinations that the sky on the planet Earth can have. I give it 2 examples, sky is blue, sky is orange, and then my query, the sky is, And now GPT-4 knows that it has to stick to real-world colors. This is the video for you to learn in depth about instruction fine-tuning. So fine-tuning is great. We take a base model like the MPT-30B and we fine-tune this model further for a chatbot, for an instruction, or even if you want, for a story writer task. So fine-tuned models are heavily fine-tuned for specific tasks. And it is not complicated to implement the new technologies we have today, July 2023, like flash attention. Look, 2 lines of code. You have from OpenAI to Triton, the GitHub repo, 2 lines of code, and you can use this new technology for your models. And the next interesting thing is prompt engineering that you will have, or in-context learning. The great thing is you can use it on the closed source and on the open source model. So prompt engineering is there for every model that we have. But you have to understand how it works and where it is different to the fine-tuning approach. Now, what is a prompt? Look here, this is my GPT-4 system. This sentence here is the prompt for your input text to GPT-4. This is the prompt with a length of 8,000 to 32,000 tokens. If you say, who needs this? This is my first prompt I used on GPT-4. I have a loop that I formulate in a natural language, like English. I have interrupts, how to leave the loop, what to do afterward. A lot of commands, and GPT-4 is able to get a logical structure and perform the task I describe here in my natural language. If you say you want to be more professional, you can use something like, we say, an API, an application programming interface. And OpenAI, for some money that you have to pay, is providing you an API. It is a set of rules and protocols that allow software application to commute with each other. So if you like this approach, this is the video for you. OpenAI API, I show you how to code it. I give you some free examples and I show you the code and a free Colab notebook or a Jupyter notebook if you want, where you can jump into. But remember, for the API functionality, as always, you have to have your credit card ready and pay. Some new technologies like Flan instead uses fine-tuning the model on a large set of multiple instructions that use a simple and intuitive description of the task. And when you evaluated this training methodology, they found that Flan outperforms the normal zero-shot systems. However, for prompt engineering here, the scale of the model, the size of the model, a 7B model, a 13B model, a 40B model, or a 220B model is important. Bigger models are more intelligent and are able to generalize from instruction in the training data set, either in the fine-tuning or in the prompt engineering. Now you know pre-training, fine-tuning, and prompt engineering. And this is great. You have already become almost an expert. So to sum it up here, on the right side, you have here prompt engineering or in-context learning. Wordings are zero-shot, one-shot, and few-shot. And on the left side, you have the fine-tuning. Another new technology in 2023, chain of thought. Here you have here in, let's say this is blue, 2 examples, chain of thought and chain of thought with instruction fine-tuning. So these are the examples you provide to the machine to learn. Interestingly, you can combine chain of thought and instruction tuning and use it together and improve the model's ability to solve complex unseen tasks. Great. Instruction help with a clear command. Chain of thought are more on the explanatory step-by-step approach. And now we connect our LLM to the outside, to the other world, to the other data centers, to all the new data. So How we do this? We connect our AI with agents. What are agents? Look here on the left side on my GPT-4 prompt. I have there some sentences that contain data. And I have this data brand new from external data, like a vector database, a SQL database, some document servers somewhere on the internet that all have an API to access this over the internet. And remember, for each API, you have to pay. So now I ask GPT-4 for some external data published today that are available in the database. And I use my natural language in the query. And then I say to GPT-4, now you write a SQL query for the specific database to interact with the database and get the data from this database. And you see the dark blue lines inserts now the data into my prompt. We use here a new functionality by OpenAI API called function calling, which is just a short Python code sequence we call also an agent. And an agent is task specific and performs my command that I programmed to get new data. And the beauty of agent is they can work in parallel to access GPT-4. 2 videos to learn more about vector databases and go beyond vector databases, and 2 specific coding videos on function calling and multi-agent system. Now to the most important, the training data. We need the training data for pre-training, fine-tuning, prompt engineering, and we have the data in our agents that we access. Data are everywhere. Data determine everything. Hugging Face provides to you 46,000 dataset, not just for natural language processing, for computer vision, for multimodal system, for audio system. You have datasets you can't even imagine that there's a dataset, but it is there. It is free of charge on Hugging Face. But watch out, you have license requirement, legal licenses. Please respect the legal licenses of the dataset that you use to train your LLM for specific tasks. In words in sentences have a linear structure. And GPT, autoregressive system, predict the next word. This is easy. This is a chain. But now build a chain in 2 dimensions. It becomes more interesting. Social media contacts. But why stop at 2-dimensional systems? Go to a 3-dimensional systems. Graph theory, mathematical graph theory, where you have node and edges and higher dims. Node have a feature tensor where all the information of the node is stored in them. Edges have edge tensors. And graph neural network can now predict node classification tasks or edge predictions. And here we have the fusion of 2 big mathematical frameworks. Large language model, and now suddenly combined with graph machine learning that incorporate here very dense, very complex data structure. If you're interested here, how to do this, here's my video on graph machine learning and the interaction with LLMs to build a causal AI system. Thanks to Stanford with this new methodology we call Prodigy. So you see, there you have your 5 points. And when you know how to input graph data into a prompt, I say, welcome to the 2nd level. You achieved it. Now you know the basic terms of large language models and generative AI. I say thank you for watching. Thank you for listening. I hope it was informative for you, and it would be great to see you in my next video.